Welcome to Auto Deploy K3s to the Edge with SUSE Manager. And this is a best practice 1041. And today's presenters are myself, Cameron Cedar. I'm a technology strategist at SUSE.
And I'm Don Vosberg. I'm a pre-sales consultant also at SUSE here in North America.
Fantastic. So let's first explore why you want to auto deploy on the edge.
It's always a good idea to know why you're doing something before you start.
Well, you know, incorporating a little bit of Disney magic into anything is not a bad idea. But things you might want to do at the edge, creating a K3s cluster. And maybe you want to take that to the next step and actually connect it to a Rancher server and automate that whole process. But you have other things, right? Things that are, you know, that cause a lot of headache and pain, and those go back to some maintenance tasks, you know, being able to do security scanning, applying patches and updates, you know, creating virtual machines, you know, various types of monitoring of the system, you know, doing certain levels of content delivery at the edge. Maybe it's taking containers and putting them into a registry, you know, at the edge. Scheduling of, you know, various updates on a specific maintenance window that you have scheduled. And also being able to do all of that at scale to not just dozens, but hundreds to even thousands of systems at, you know, various sites across either North America or the world.
And all of these requirements actually came to us from customers. Isn't that right, Cam?
Yeah. And we've actually had several customers asking, and this is actually why this was actually created, to fit some needs of current customers today.
What are the core design components, and what are we doing here with this stuff to deliver that Kubernetes at the edge? So here's some of the pieces that we used for this solution. SUSE Manager, which gives us the image building capabilities, managing virtual machines, and a Salt Master, which gives lots of options for automation and deployment, and you'll see that in place as Cameron demos it. We use SUSE Linux Enterprise for a couple of different purposes in this demo. We use it as the build host, where we actually create using Kiwi to build a virtual machine that we subsequently are deploying. And we use it as the hypervisor server. So it's running KVM and libvirt as the hypervisor in this scenario. So obviously at the edge, you have enough horsepower at this edge to be able to run at least a small scale hypervisor. And Cameron will show you some of that. In the data center element, we also have a Rancher server. So Kubernetes management, if you're building containers, you want to manage it, Rancher is fantastic. And of course, we're integrating that into this solution as well, so that when we deploy, it makes use of Rancher's capabilities right out of the box. We've also incorporated Longhorn as persistent storage behind the cluster. And again, that's a Kubernetes piece. And for the actual Kubernetes distribution itself, we are using K3s, which is Rancher's fantastic edge Kubernetes platform that can be quickly deployed and run on systems, offering you a full-blown Kubernetes without a lot of the complications. So those are the design components that we used in this solution.
Yeah. And these could absolutely be, you know, customize these to fit other solutions. You might have some other ideas of incorporating another open source technology that fits into the mix of these to enhance your solution the way that you see it.
So how did we design this, Cam?
So if we look at these, I've got a couple of design diagrams which we can deliver this solution today. Looking at the data center or cloud point of view, we have the Rancher server, which is actually misspelled in this slide. We don't want to remember anything at all, but
how did that make it through all those edits?
That's okay. Everybody knows it's a server. But SUSE Manager is also part of this data center infrastructure, along with what we call a build host, which incorporates things like Kiwi from SUSE's open source technology to actually build images or even build images for containers. And it's pulling the configuration files for that from a GitHub source. And so the link to the edge here is that it's actually taking that output of the build host and incorporating that into an HTTPS location that can be delivered through that content delivery mechanism to an edge device. And in this case, in this design, we're delivering it to some virtual machines. Virtual machines running on top of a KVM host that is SLES 15 Service Pack 2 or higher. And Rancher would be, of course, managing that K3s cluster that gets instantiated by that virtual machine or virtual machines, depending on how large that cluster might be. These edge servers, some of them are large. This is a picture of an EL1000 from HPE.
So this is not the far edge, right? This is the nearer edge.
Yeah, I would say this would be more of a near edge. I mean, it could be a far edge, right? I mean, it's, a far edge might be incorporating something else that's missing in this design, and that is a SUSE Manager proxy, right? So you might have far edge devices where you might have a SUSE Manager server delivering the content to a SUSE Manager proxy that would be operating inside of another remote location that would be handling all the content and the servers at that remote location.
And that would give you flexibility and scaling also, right?
Absolutely. Yeah, lots of flexibility. In terms of flexibility, you've got other things that you can deliver, like you can use it for content delivery of containers, right? You want to spin up a container registry at the edge, use SUSE Manager as that content delivery mechanism to send those containers to your end registry or your edge registry that's sitting out there.
And today, this represents a real world deployment where we have both container applications and we have applications that require VMs like that Windows application, right?
Yeah, exactly. Yeah, so very flexible there. Yeah, incorporate Windows into that content delivery. That's more flexibility that we can drop into this. Alternatively, with this design, if you didn't want to have K3s and Longhorn running as a virtual machine, you don't have to do that. You could, in fact, run virtual machines and K3s side by side on that KVM host. So we're running containerd alongside a bridge network with libvirt. That will all work together. You could also use SUSE Manager to deliver the entire payload of this environment. So that image, the SLES 15 SP2, could be delivered as a complete image from SUSE Manager with KVM and K3s, Longhorn, everything all included at the edge.
So I could boot my edge server from the network and get all that it needs to do these things, right?
Exactly.
It's pretty cool.
Yeah.
So what our deep dive on how we're making use of some of these data center side elements in Cameron's design. So we mentioned before that we're using SUSE Manager as a server. It is a salt master that gives you the ability to store pillar data there centrally and create states that reference that. And we'll talk about formulas that'll be part of what Cameron's done. But by using this, we have control of the patching and updating lifecycle of any deployed Linux within that infrastructure. So the virtual machine server itself, VMs that are running K3s on top of that, both in the deployed format of the registered systems themselves, or in actually controlling the lifecycle of the image that's used to build those. So as Cameron mentioned, we're using Kiwi to do image building, and that image itself is inspected by SUSE Manager, and its lifecycle can be managed. You can rebuild them and incorporate newer patches and updates as you go along. It has the ability to do auditing and monitoring, so you can know who did what action when. And we have the ability with Prometheus to be able to do monitoring all the way out to the edge. We're showing virtual machine host management for the KVM environment in this deployed scenario. And that gives me a web browser front end to KVM. So I don't necessarily have to be right at the place where I'm deploying. I could centrally deploy even out at the edge. And of course, the automation framework that SALT is provided gives us the ability to quickly install K3s and automate it with some forethought. But the automation itself, once it's complete, is rapid, and Cameron will show you this in the demo. Creating and registering a cluster in Rancher and installing the Prometheus exporter or anything else that I need installed on my systems that I'm doing this automated deployment of. On the Rancher side, obviously Rancher is where we are registering our Kubernetes clusters. So in this case, it's K3s is the distribution. Those K3s clusters get registered and created up there. And I have the option inside of Rancher to actually upgrade the Kubernetes version. So as things come out of my applications require newer versions, it can do a rolling disciplined upgrade of that by not disrupting and cordoning off nodes and keeping workloads running while I'm doing the upgrade process. Of course, integration with tools like Git are important, and keeping your application lifecycle in place. And then, of course, monitoring on the Rancher server itself and logging of the container-based applications, deploying with Helm charts. Those are all things that Rancher server is fantastic at.
Yeah. Yeah, what's interesting on the SUSE Manager side, we also have Prometheus, right? Rancher also has Prometheus. And a nice integration from the SUSE Manager side is the fact that it's got federation built in for Prometheus.
Right, where you can have Prometheus reporting to a Prometheus, and then when you create your dashboards, you can see the aggregated or separated data depending on what elements you choose.
Yeah. Yeah, that's, again, another powerful thing you could actually add into this solution that would make it that much better. That's awesome. Oop.
So how does our image flow, Cam?
So I put this in here just to illustrate kind of um, how you would take this image from SUSE Manager that's been created by the build host and get that all the way to the edge server. Because I think if you illustrate it, you can better understand how we're getting it there, and also understand that there's some elements here that are not typical of other types of edge solutions that are out there. So starting from the SUSE Manager server with the SLE build host, you have to be able to have the ability to create a specialized image, an image that's going to run an operating system that is small enough, that just has a small footprint of software that can be managed by SUSE Manager, and also roll new versions, being able to maintain that image. So we're building that image with Kiwi, and we're using an image template that's stored in GitHub. And that image template can be modified and updated if you wanted to add in new things to the tool or to your image at the edge, or if you've got some new monitoring tool you want to incorporate or something like that at the edge, then you could add that to the image, right? There's full flexibility to make updates, enhancements to what's going on here. So you build the image, then the image is published to a special location, an HTTPS location called OS Images on the SUSE Manager server.
And because we're using KVM, we store them as QCOW2, but you have the flexibility in the tool to store them in other formats, right, Ken?
Yeah, exactly. So if at the edge you're running, say, VMware or even Hyper-V, we're able to create those kinds of images as well. So those virtual machines will run in other hypervisors. But the most important thing in this whole flow of things is really the bootstrapping of it. And this is where, we take an age-old technology that really has been around for, 20 plus years. And we are incorporating this into an edge strategy. We've got to be able to, get the software, the operating system out to the edge. And so we need a way to do that. I mean, one way, of course, is, well, you can drop ship an appliance and then somebody goes out and, installs the hardware at that location. Another idea is, well, you have somebody, take this image that we've created with SUSE Manager and copy it into a thumb drive, and they boot that system up that's at the edge from the thumb drive, and then it communicates back to the SUSE Manager server. But then you have to have a smart guy at the edge that, that knows what he's doing.
And smart guys do not always scale, right?
It's true. Unless you're paying to fly that guy around the country at your 100 some odd locations or whatever. Yeah, one guy doesn't scale to 200 some odd locations or whatever it is. So that doesn't really work very well. The better scenario might be, let's put a SUSE Manager proxy at that edge location, and then we get the ability to do PXE booting, and then we can control everything from the hardware layer, everything that's at the edge, right? The edge servers, and really anything else that's there. Of course, we are only concerned with those edge servers because we're going to deploy SLES on them, but you could do other things. But that PXE boot environment is absolutely critical to getting that image on there. So once you deploy using PXE boot, it goes through this activation process with the SUSE Manager server, and then starts the execution of some special salt states that you've configured, and then goes through this magic process, this automation.
Yes, I noticed all three of the ones on the other side of the salt states say auto, 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 and that helps helps them on me to have a better weekend, I think.
Absolutely. All this automation built into to register to the Rancher server, install the K3s cluster, get Kubernetes up and running, is completely automated. Once that's all done, you could add in other automations as you see fit for the solution. Maybe you have special applications you want deployed once this is actually all complete.
What are the results of this? When we're all done deploying all this, now I have deployed instances. So they may be virtual machine instances or and images that I'm able to redeploy then that are fully manageable by SUSE Manager. So I haven't just created them once and now they don't get touched and I never see them again. They're registered and visible to me in SUSE Manager. I have automation also to add more nodes if I need them, more K3s agents to my cluster, more clusters if I want to create new ones. All of that is available to me to do in future. And immediately on creation, these systems are registering themselves and becoming visible in Rancher for me to be able to install container-based applications and manage storage there and do all the great things that Rancher is capable of in managing Kubernetes. So now, Cam, you get to show it to us in a demo.
Fantastic. What we've all been waiting for. So I'm going to open up a couple of different screens here, a couple of browsers. And here we are. So on the left side, I've got Rancher, and then on the right, I've got SUSE Manager. Now I'm going to focus completely on SUSE Manager for now, and then we'll go back to that split view here in just a minute. In my environment, my demo environment, just to give you a little bit of context, I'm going to show you this virtual machine manager because it is mostly in virtual machines. At the very bottom, I've got this thing that says NUC1. That's a KVM host that actually is going to have virtual machines deployed on it from SUSE Manager. I have Suma, which is our SUSE Manager server. I've got master and then 5 workers, which is a Kubernetes cluster that actually runs Rancher. And I've got some other things in here. Here's our SLE build host as well.
So in this scenario, the SUSE Dojo server is your data center, right?
That is correct. SUSEDojo.com is my data center. And we can see a similar view here in SUSE Manager. He's managing some of them. I've got my build host, a couple of NUCs, and some other virtual machines here. Under NUC1, we can show that this one actually has, if you look at our formulas, he's been installed with the virtualization formula so that he can actually manage virtual machines from SUSE Manager. The SUSE Manager formulas are basically just a collection of salt states together. So you can select these and it will auto deploy these things. And it actually comes with a set of configurations that you can apply. And those configurations can be modified at any point in time. So that's formulas, a really powerful tool. So that gives me this virtualization tab now. So I'm actually able to go in here and I'm going to coin this the JE VMM. Just enough virtual machine management.
Yeah, it's not. It's great for Edge, right? Because the expectation is I want to be able to web-based manage virtual machines. I'm not trying to be vCenter.
Yeah, it's definitely not vCenter. It gives you all the basics that you require. Launching virtual machines, starting and stopping virtual machines, just all the basics that you require for handling a virtual machine. If you want to do things like, anything that's special beyond that, like, failover, HA with virtual machines, that's not something that's built into the interface. But that's okay. Maybe that's all you need. Maybe that's all you require. There are ways of setting up, HA using salt states to be able to handle that configuration, because it is just some configuration in KVM.
And here we're trying to deploy Kubernetes on the edge. So how do we do that?
And so the way in which we do that is we're going to take an image that we're going to deploy here after we create a guest, right? The image, as I said before, is put into a special location, which is here, this OS images location from SUSE Manager. And I've got a few images out there already that have been built using our build host. The two that I'm going to focus on is this one at the bottom, which is our, I'm going to copy the address for it. This one's for our master K3s node, and the other one's for the agent. Or you could call it server agent in Rancher terms. Going back to the SUSE Manager server, we have on the left-hand side, we've got images. This is where all the images are actually created. And you'll notice right off the bat that all these images here are completely out of date. They're 2 months old. The last modified was 2 months ago. And so they haven't been rebuilt. What's really nice about this tool here is I could actually drill down into this image and I could actually rebuild it. So it's monitoring the state of my images and checking to see whether or not I need to rebuild them or not, making sure that they're completely up to date. So I can actually, if I need to deploy new servers, I probably want to deploy them with something that's the most up to date that I can get. So I want to rebuild those images to incorporate all the latest and greatest patches. So I can click the rebuild button and it will rebuild a new image with all those latest patches. So that's a nice maintenance technique for maintaining images. So for any new systems that you create, you'll want to have the latest and greatest images that you've built. Similarly, this can also be used for container images as well. Going back to systems, if we take that image that we've actually built, we'll go back to our KVM host and go to virtualization, and we'll create a guest. We're going to call this one K3s1. I'm going to give it some memory. 4 gigs of memory should work out just fine. And here's where we put in that source template image URL. This is where it's going to pull from. So this is going to be our disk, in fact. It's not a very.
And this is the output from your build host, right?
Yep. This image is actually built to incorporate a specific size image, and I could actually create that image for any size actually that I wanted to. If it's a dynamic image, I could incorporate the size here, and that image would be instantiated with that particular size. But you'd have to configure that in your profile. I'm going to select a MAC address. Now this is a MAC address I have already configured in my DHCP, and it's associated to a host in my DNS. And then I'm going to go ahead and create it.
That way when your machine comes up, it doesn't look like it's localhost. It has a real name, right?
Exactly, or some IP address or whatever. So the scheduler is basically waiting to do some work. He hasn't picked it up yet. It runs every minute, so we're going to sit and wait until that scheduler picks it up, and then it will kick off that work over at the NUC1 server. And if I wanted to, I could watch the events. We can see that I do have that pending event waiting for the scheduler to pick it up. And he's picked it up.
Look at that.
He's going to launch that virtual machine. One thing that's really nice, you know, I talked about how this is JEVMM, just enough virtual machine management, but it does have the ability to visualize the console. So that's really nice. So I can see that the system's booting up. Once it gets to a login prompt, I know that it's actually doing some extra work after that, some automation that we've been talking about. So he's almost there. All right.
There it is.
Login prompt. And now we should be seeing some things happening in our overview. We've now see that it's registered to SUSE Manager. So now we have the K3s server. He hasn't quite figured out, you know, all of his updates, but I can take a look at what events are happening on this this system and look at history. The scheduler's picked up all these events, so now it's doing a hardware refresh. It's getting to know what hardware is installed there, and then it's going to figure out what the software channel layout's going to look like, and then you know, whether or not it needs patches and updates. And we know that it does, because that image that we sent out there, it was an image that was out of date.
It started out slightly behind the curve, didn't it?
Yeah, exactly. And then it's going to apply some other high states that we've set up and configured to do the K3s and Rancher stuff. Now let's see how far along it is. I'm going to look at the double view now again, the multi-pane view, so that we can see what
that. You've got a new cluster in Kubernetes in Rancher. Isn't that awesome?
Yeah.
Hey, so now it has a node.
So it's created the cluster. Now it's added a node. So it's going through all that automation on that K3s server. So we now have a new Rancher cluster called demo K3s. It's got one node, and notice the provider is K3s. Can't do much with one node. You know, I mean, you can deploy some software, but you're not going to get much high availability out of that. So at the edge,
is it a cluster if it's only one?
Exactly.
That's the question.
In some cases, you might just want one node at the edge, but if you want high availability at the edge, you're making your applications a little bit more resilient, then you're going to want 2 and 3 nodes within your cluster. And we can do that really simple and easily with SUSE Manager. We can actually add in an agent. So I can go back to that NUC1 server, go to the virtualization. I can create the guest. I'm going to do K3s2 in this case. I'm going to give it some memory. And how about 2 CPUs? And the image template that I want this time is the agent template. I've already got the autofill in there. It's in my list, so I'm going to just choose that. The MAC address is going to be the 22 MAC address, since I've already got this set up, and then hit create. Again, the scheduler is going to pick this up, and let's see, it's sitting there pending in the list. So it's waiting for it to be picked up. And it'll take just a moment. Like I said, it runs every minute, so depending on when you catch it, you might have to sit there and wait.
Using a NUC as the host machine makes it somewhat like a near edge, where it's a tiny device, but it has enough power to be able to run virtual machines and clearly container systems on top of that. So, and give you the flexibility to do both VMs and containers. And we have a customer who has something like Cameron pointed out earlier that's even more powerful than a NUC. But here in this environment, you can see the demo cluster coming together.
There is actually one real world use case where they're using NUCs today. It's a published story on Chick-fil-A. If you're familiar with going to their restaurant and getting some Chick-fil-A, every Chick-fil-A restaurant, as I understand it, according to the story, has 3 NUCs in each restaurant, all running Kubernetes on it. So absolutely a real world story there. So let's see K3s1, he's at a login prompt, so he should be doing some automation now. We still have 1 node here in Rancher. Right now he should be going through several different events. He's registered. He's also
There
added
it is.
node.
It's coming
So
in.
he's instantiating K3s2 to the cluster.
And there it is.
There
We
it
have
is.
a 2-node active cluster.
2 nodes.
That's amazing.
So if we go to demo K3s cluster, we can take a look at some basic metrics of the monitoring of that cluster. If I want to go ahead and look at the cluster explorer, I can use this cluster now. I can deploy software to it. I can see all the deployments that are actually running there. These are just the basic K3s deployment. We've got the fleet agent, the cattle cluster agent, traffic, which is for ingress on K3s, and then core DNS. Pretty simple cluster. And that's it.
Great. Thanks for the demo, Cam. It's fantastic. So
maybe we'll get this in presentation mode.
Or maybe not. Oh, it already is there. There it is.
There we go.
So for additional resources on this topic, Cameron's created a nice GitHub account with a link here for you to be able to see all of what the elements we used for this demo. If you want to see it in deeper look, it's a part of the demo showcase where we go into much more detail about what we did. And this is Cameron doing it, not me. And then there's a best practices session on edge computing and orchestrating workloads, which you might find very useful if you enjoyed this type of presentation. 2 more demos that are part of the showcase, one for Longhorn, which is the storage element part of what the Rancher portfolio provides for Kubernetes, and particularly Longhorn for edge. So it's be important where you don't have other type of centralized storage to be able to add something like that. A Rancher demo on managing Kubernetes and the edge, super helpful. And of course, Kubernetes multi-cluster management with Rancher, getting started there itself. There's a tutorial session on that here at SUSECON. Thank you so much for paying attention to us today and for entering into our world of automating K3s at the edge. Thanks again.
Thanks, everyone. Thanks for joining.